I'm going to do 2 quick problems just to get you acquainted with how this worksheet is going to work. That way, if you're not sure, you can use this first before moving on and checking your answers on the answer key. So we're going to use our knowledge of vertex form of quadratic functions to sketch each quadratic function as it compares to the parent function y equals x squared. So this parabola, y equals x squared, is the parabola that we compare all other parabolas to. When we talk about a stretch or a shrink, we're comparing it to this one. When we talk about it opening up or down, we're comparing it, and the vertex we're comparing to the vertex of this parabola. The vertex should be the only part of your graph that's marked clearly and accurately. The rest can just be a sketch based on what you see in the equation. Remember that a parabola's shape, opening up or down, will depend on if the coefficient is positive or negative. Stretch or shrink will be determined by the coefficient absolute value, the a value, and the vertex is determined by the values of h and k. Remember, if h shifts the parabola right, if it's minus, if it's plus, it will shift it left, and k will shift it up or down. So the first box here isn't even a problem number, it's just showing you all the characteristics of the parent quadratic function y equals x squared. The vertex is 0, 0, so I'm going to label that. There's no horizontal shift, and there's no vertical stretch or shrink. It is not shifted up or down, and it opens facing up. The axis of symmetry, remember, is the vertical line that divides my quadratic equation in half, or parabola in half. I could draw it there, and the equation of the axis of symmetry is 0. This function has a minimum value. It has a point at which it reaches its lowest, and the minimum value of this function would be 0. The minimum value is only the y-coordinate of the vertex. So the vertex is made up of an x and a y coordinate. It's where the minimum or the maximum occurs, but only that second number is the minimum or the maximum value. Let's look at the second example. So we're going to sketch below, but we're going to begin by using our vertex. Since I do not have an h or a k value, that means my vertex would also be the point 0, 0. So I'm going to begin by graphing that here. The rest of my graph can just be a sketch based on what I see in my equation. Since my a value is a positive 2, I know that means my parabola is going to open upward, and it's also going to be a vertical stretch compared to the parent function, which means it's going to be skinnier or narrower. So right now I'm not doing it 100% accurately, I'm just showing that this quadratic equation would be narrower compared to the parent function. The horizontal shift did not happen. It was a vertical stretch, and it did not shift up or down any spaces. It still opens upward. My axis of symmetry I can represent using a dashed line. The reason I use a dashed line is just to show that it's an invisible line that would split the graph in half, and its equation would be x equals 0. Again, this quadratic equation has a minimum value. That minimum value occurs at the vertex, but it's only the y value of the vertex, or 0. So I'm going to jump to problem number 3, and first I'm going to find my vertex. Since I've got 3 being subtracted inside the parentheses, that means x minus h. My h value is 3, and I've got a plus 1 in the end. My k value is 1. So that means my vertex is going to be over 3 up 1. That's the only point that I need to graph with 100% accuracy. So my horizontal shift was right 3 spaces, and my vertical shift was up 1 space. Vertical stretch or shrink, I'm going to look at the coefficient of the parentheses, or my a value, and right now I've got an invisible number 1. That means it's going to be the same size as my parent function. That's going to be important because when I sketch my quadratic, I want it to look similar to this. I just want it to have a vertex here. So if you can picture yourself translating over that quadratic function, that's what's going on. I could even copy this one and then drag it over until I get to where my vertex is. Now I know that they're the same size. I also knew that it opened upward since my a value was also a positive 1. So it's going to open up as well. My axis of symmetry this time, if I draw it, looks like this. And that's the vertical line, that's x equals 3. This quadratic equation also has a minimum value, and it's a minimum value of 1. So a minimum value of 1. Again, your maximum or your minimum occurs at the vertex, but it's only the y-coordinate of the vertex.